we throw it away, let's look at it a little bit deeper. Origami looks to produce a specific outcome. There are prescribed steps in a specified order. Many of the operations are the same, but they're just used in different ways. When you're using origami, you're going to find that a lot of the models look almost identical for the first number of steps. There's just a few forms that can be expanded into a whole bunch of different possibilities. I think that this puts origami well within the spectrum of computational thinking. So let's go through the process. The first step in computational thinking is decomposition. Origami patterns can be broken down in a variety of ways. Of the patterns that I created, and a couple more, all share the first 6 or 7 steps. Then it's only the last few steps that have any difference that make this shape what it is, this sculpture into what it is from that basic shape. After these general forms, you can break down even further. Every single one of the forms is made up of using just 9 different folds. So we break down the elements into generic shapes, we break down the generic shapes into their folds, and we can see that we get from a small number of tools a wide variety of structures. This leads right into pattern recognition. These specific shapes, these general structures, these are patterns. Once you learn these patterns, the process of folding your paper into an origami sculpture becomes much easier once you see these general forms. Once you can work towards these generic shapes, it makes the whole process a lot easier. Now, instead of having to learn all the steps for every single structure, you're only learning the couple steps at the end that differentiate one from the other. This is the essence of pattern recognition. You're looking for smaller repeating patterns that allow you to make a larger whole. This process is also pattern generalization. We're looking for generic shapes, generalized shapes, repeated patterns, tools that we've learned in one situation or applied in one situation that we can use again in the next situation. The other process with pattern generalization is abstraction. Abstraction really is the creative part. This is where you can take that general shape and decide whether or not it's going to be a head or a horse or a swan. So from there, you have to be able to take those general patterns and abstract them and make them their unique structures. Once you've done this, it's time to go back, figure out how you did it. Make sure all the steps are in order. That's your algorithm. Look up any origami design. They're all based on a number of steps. You can look up the directions on how to do them. This is an algorithm. An algorithm, a set of steps that you can go through to get the desired outcome repeatedly again and again. That is origami. It's like computational thinking. Developing one of these models or developing one of these patterns or sculptures is computational thinking. And if you don't believe me, I haven't convinced you, then I'm going to put a link down below, and it's going to take you to a page, a video from the MIT laboratory, where they have a robot that actually folds itself and then goes around and completes tasks. This robot starts as a flat little structure with a little magnet and folds itself. It's even called Origami Robot. The designer took inspiration from origami. So this whole idea of these folds is actually applied in robotics. Not all robotics, but this is a very interesting structure, and some of the things that they talk about possibly being able to do from this general idea is quite fascinating. So, do I want you to go out and spend all your time learning how to fold cranes or frogs or horses? No, that's not my goal. If you want to and you have fun with it, that's great. But what I want you to do is, as you're going around, as you're doing your daily tasks, see how many of them actually are done with an algorithm, either implied or implicit. Then, also, how many of the things you do could benefit from an algorithm? How many of your tasks could be shortened, could be helped, if you just had a set of steps designed to do things the most efficient way? So as you're going around, take a little time to think about what in your daily life could benefit from a little bit of computation.